Yeah, there we go. Hey, welcome everybody to Astronomy Daily Live. We've got a little bit of coffee left here. I've been sipping at that. It's still a little bit hot, but it's really low. It's just a little, just a couple more sips. So cheers. Hope everybody's doing well. Mm. Ah, all right. Well, hope everybody's doing well. Yeah, things are good. Things are good here. It's cloudy, monsoon cloudy. So nothing going on there, but I've got tons and tons and tons of data that I still have to go through. So I'm not itching for any more data at this point. So I definitely have enough. All right, well, cool. So this is just a daily gathering of friends. I start this at 2 hours UTC, practically every single day. Once in a while, I'm not able to be here, so uh, because I'm either not here or because the power is out, or something last minute came up that needs my attention. Whatever, right? Really, really casual fun here. So this live stream is just sort of an extension of something that I've been doing personally for oh, a very, very, very long time, decades. Now, here in this particular place, I've been doing it for ever since we moved here. So that's a long, long, long time. That's like 14 years or something like that. Yeah. So each and every evening. Now for me, I'm 7 hours behind UTC. I'm on Mountain Standard Time down here in southern Arizona. Um, and Arizona is one of those places that does not observe daylight savings time. So we are always on Mountain Standard Time, which is always 7 hours behind UTC. So it's 2:02 UTC on the 26th of July 2019. That is the UT date, but my actual time here is 7:03 p.m. Mountain Standard Time. So, it's sort of the end of my day. I've pretty much finished everything I was going to do. Had some dinner. I sit down here about this time each and every day and just spend a little bit of time going through all things astronomy and space and science, and just sort of, read some papers and look at some pictures, and think about the state of astronomy, and how that's going, and think about personalities and institutions and all that. And then a year and a half ago, it's like, well, you know, uh, I do like to share this kind of passion. I have a lot of it to share. So it's like, get yourself a little webcam, plug it in, and just so I'm doing here exactly what uh, um, what I've been doing for a very, very long time. The only difference is that I'm talking out loud, right? If I'm just going to sit here and read some papers and whatnot, I'm not necessarily going to be talking out loud. So I'm talking out loud for you, but this is just a train of thought thing. I'm not trying too hard, to edit or act a particular way. This is it. This is it. Except I definitely do not talk this much. I'm a pretty quiet dude. I like to just sort of sit off in the corner and listen. I really, really like that. It's not that I'm shy. It's just I like to hear uh, what lots of people have to say, and I I just like to sit back and listen and observe. I think this is a very, very fascinating universe, and one of the really interesting things uh, are is us. We're really kind of weird. Always fascinating just to observe um, uh, this weird behavior that we have and take so much for granted and don't really ever even think about. Um, but being a scientist, I have to, my second favorite word, by the way, is why. And that is what we learn uh, as a 2-year-old, right? Every single thing is, why is it like that? Why does it have, uh, why? And so that's where science starts. And unfortunately, a lot of us lose that, I guess. I am one of the lucky ones to have never, ever, ever lost that. I very, very distinctly remember being so just insatiably curious as a very, very, very young kid, 4 or 5 years old, just like just wanting to just absorb everything. And that feeling persists. It hasn't gone away. If nothing else, it is expanded. It's grown because the more you find out, the more whys you can answer, the more whys there are. So it's not really all that fair. But for creatures like us who are just sort of naturally curious for some reason, um, uh, this universe seems to be like really, really ideal, because it's not. There's some problems in it, and there's some weird things going on that we keep trying to figure out, and we think we have the answer, and then you know we 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 um, we take a harder look at things, and we notice it's like, wow, and what we're thinking isn't quite right, so we have to change things, and you go through revolutions that way, and there have been several. And I think we're coming up to a point where maybe there's going to be another revolution. I think it's about time. It's about time. Um, Hard to know what exactly it's going to be. You all know that I'm 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 impressed with the electric view of the universe. I think that you know if what I was taught as a student astronomer is that 99% of the universe um, uh, um, is in a state of matter called plasma, and plasma is um, inherently charged, because these are atoms that are uh, either missing electrons or have too many electrons. So they're ions, right? That's what that is, and that's a plasma. Um, and plasma has many different forms. It doesn't have to be in a very uh, um, big energy kind of thing. Plasma exists in these different modes depending on the local conditions. So anyway, that's an intriguing one. It's you know there are some holes And the frustrating thing is that it's sort of new enough that even the people who are like you know, have really worked on this for a long time don't still, at least as far as I'm concerned, don't quite have their heads wrapped around everything yet. Once they do that, then what they're going to be able to do is they're going to be able to um, predict observations. Now they've made some predictions, um, which when you look at the data, it's like, okay, yeah, that's a possible interpretation of what we're observing, right? It's sort of a viable thing, but yeah, I think we need a little bit more. At least I do, to really be convinced of that. The other interesting thing about the electrical concept is that me again, being a student physics major, I was actually a double major. Um, uh, uh, we are taught that the electromagnetic force is 39 orders of magnitude stronger than the gravitational force. So if you think of it in a different way, a change in one sort of electrical potential, right? One unit of that electrical potential is like 10 to the 39th gravitational units, right? That's a huge difference. That's really, really, really big. So it doesn't take a lot for the electrical force to really uh, um, uh, counteract and overcome any kind of gravitational force. I'm thinking that gravity might be some kind of an emergent thing out of electromagnetism. It's hard to tell. Hard to tell. So, but yeah, I think astronomy and maybe even science in general is um, rapidly coming up to some kind of paradigm shift. I think we're due. I think we're due. So we'll see. I'm going to look at the chat because I want to say hi to everybody in the chat. I've been just babbling for forever here. So Tom, hey, Uncle Bill, 30 seconds late. Me or you? Carolina Sky Astronomy, hey, great to have you here. Yeah, why? Why? Curiosity, as I said, is one of the three legs of science. You've got to have that as your motivation. I was 30 seconds late. Yeah, I was looking at something. I forget exactly what it was, but I was looking at this, and then I realized it was time to go. So you're right. You are right. Yeah, Carolina Sky. I'm not sure about design. That's you know, unfortunately that has become sort of a catchphrase of sorts. It's yeah, I maybe there are some things that just really aren't worth knowing. So whether this universe was designed or by some miracle it just sort of appeared. Whether it's a simulation, right? Um, Anything like that. It's like, well, does it really matter all that much what this actually is? Um, you know, or can we just sort of sit back, relax a little bit, and just enjoy? It seems to be a pretty nice place. I mean, it's a challenging place, but we humans are just making it much more complicated than what it should be. So, but yeah, it's curiosity is definitely a great motivator for that. All right, cheers. I've got lukewarm coffee here. All right, but I do have, of course, a couple of moles of HOH in here. So cheers to that. All right, great. Well, last night we were looking, or yesterday, I should say, we were looking at the what was it called? The ring moon. I've got it here. The ring moon systems node. That's part of the planetary data system. And we looked at just one little part of that. And I'm looking at the site now, as you can probably tell. And yeah, I think I'd like to sort of just browse around this and mess around a bit. There's a lot of links over here, and I'm kind of curious to see what's up with all of this. But right before I do that, I just wanted to provide a little bit of an update on the 30-meter telescope controversy over on Mauna Kea. So I guess the road is still being blocked. There's a group that I guess today. I guess that was supposed to happen today. I think the article said Thursday, and that's still today. There was a group that was going to march in favor of the 30-meter telescope. So, the fact, and this group is a Hawaiian group, right? So they are in favor of telescopes being up on Mauna Kea. The opposition is saying that the site has been mismanaged for 50 years and therefore is being desecrated. I think that's the new word. Yeah, I have no idea. It's I have been I have worked at a number of observatories down here in southern Arizona. I've worked on Kitt Peak. I've worked on Mount Hopkins. I've worked on Mount Lemmon. I've worked on Mount Graham. I think those are the four. Yeah. And I never ever saw any kind of mismanagement at all. In fact, on the contrary, there were rules, right? Being an observer or being a worker up there, and I've been both. There are certain rules, and if you don't follow these rules, you are told that you will follow these rules, and you'll get a call from the director saying, "Hey, act right," but nobody ever did, right? Because it's like, this, and like I was saying the other day, to us astronomers, this is sacred ground as well. There's like huge respect, and everyone who's there feels it. It's this really amazing power that's right there at the top of these mountains, and so we like it too, and we don't want to mess it up at all. Zero. That is there is no tolerance for that. And like I said, I never ever saw any of that. Oh, I worked at Palomar as well. Worked there a few nights. And no, Palomar Observatory is spotless, is absolutely spotless. It's beautiful too. You know, the facilities. You know, there's a kitchen and there's a dining room, and it's really nice. Really nice. Not well. Now this was years ago, so maybe it's changed. But when I was there, it was about 06, 07. Don't remember exactly. It was like an old style kitchen. You know, it had the tile and all that. So, but no, I never saw any mismanagement at all at any of the observatories that I worked at. It just wasn't a thing that one did. Yeah, lots of respect. So, you know, if Mauna Kea has been mismanaged up there, then well, then maybe they have a case. But you know, mismanagement is sometimes subjective. You know, just walking around on the ground might be construed as mismanaging the area, right? So yeah, and you know, the fact now that there is at least a moderately sized group. Somebody at the TMT said that the majority of the population actually wants the TMT there. So I don't know if that's true. I don't know how he would get that kind of data. You know, it's probably some kind of poll, but it's not polling everybody. So, you know, there are some error bars there. So, but yeah, it's not looking good for the opposition. But the opposition says that they are going to stay. They're not moving. So that's a difficult situation because it's you're between a rock and a hard place, and nobody's going to move. So what do you do? I don't know. Hope I guess that somebody either gives in or wears out or yeah, I don't know how you resolve that. Yeah, I don't know. You know, they've got to make a deal somehow, and you know, deals are made all the time. So you know, let's see what can be done, and just do it, right? I mean, if they, I mean, just basically give them what they want, and if what they want is the TMT to not be there, I guess they've got a problem. So yeah, I don't know. I wouldn't want to be in anybody's shoes there. That's a disaster. Yeah, probably best. You know, I mean, if these folks are really hardcore against the construction of this thing, just put it somewhere else. It's not that big of a deal. So I mean, it really sucks that we can't have our way, but sometimes Rolling Stones, right? You can't always get what you want, and that's how it is. Cheers. I want some HOH, and I'm gonna get it. All right. Well, great. let's take a quick look at the ring moon systems node. Yeah. Let's see. I'm going to share my screen. Like I always do. Don't know. This is we're into the last week of July here now, so I don't know. Still don't really know what I'm going to do. So we'll see. I'm going to do what I usually do and just try to ride. So, okay, well, here it is. Here's the ring moon systems node. And that's just a part of the planetary data system, which we visit often because, they have the best data. It's not always in the best format or anything like that for this. But if you want the science data, then you got to go to the PDS. That's the only way. And of course, this is only for rings and moons. So no planets are allowed. No spacecraft are allowed. It's just data that's associated with rings and or moons. So of course the moons are associated with planets, so can't avoid the planets all that much. But yeah, let's take a look, because I think there's a lot here, and this is what we do. We just sort of explore this a little bit. So there's planetary data, there's node resources, there's ring moon systems, various missions, resonances. I don't know about that. And then here's some folks that I guess are working on it. I know this name. This is, whoop, I'm going to go over there. I didn't mean to do that. There he is. So this guy is the name that appears if you go over to one of these Jupiter viewers. You can see it right down there in the lower left corner. There he is. So he's on every page here. So, well, let's just start at the top. I don't know. This says search. So we're going to have to search for something. Let's see what this page brings up here. Welcome to Opus 3. Whether you're new or experienced user, we strongly recommend taking a few minutes to read the Getting Started guide, available under the Help menu. Okay, well, should we do that? Getting Started makes available more than 1.5 million images and spectra of the outer planets, from Voyagers 1 and 2, Galileo, Cassini, New Horizons, and the HST. Makes it easy to perform 4 main tasks: search, browse, get details, and download. Browse the results using intuitive colored thumbnails. Wow. So searching, okay, browsing. Wow, there's a lot here. Well, let's just go for it. Okay. I'm quite sure. Let's do Saturn planet. Oh my gosh, look at all that. The intended target name represents the observer's intentions and is valid for all missions and instruments. Okay. What do I do now? Select one of these. Let's look for Titan. Is Titan in here? Here's Titan. And we'll click on Titan, see what that does. Browse results. I don't, I'm quite sure. Okay, if we hit browse, it goes into this mode. I guess these are all supposedly images of Titan. I don't know why they've color coded them that way, but kind of interesting. Is that actually Titan? I guess it must be. Should we click on one of these? Which one should we do? I don't know. This one looks kind of interesting, maybe. Click to enlarge. Oh, okay. So this was taken with Voyager. Looks like. Intended target name. That's funny. So this is a 1.92 second exposure that was taken on November 11th, 1980. Wow. Oh, there's the full res. Okay, well, that's Titan. Kind of interesting. Huh. Wonder what happened there. That's obviously something a little weird. Some motion there. Oh, it's 96 seconds. So yeah, that's probably just, I mean, I don't think the Voyager is tracking these things. So, they point the scope and open up the camera and you get a smear. But that's probably a crescent Titan, I'll bet. Probably pretty useless in terms of science, though. Maybe not. Who knows? Scientists come up with all kinds of amazing ways to work with the weirdest data. Yeah, I don't know why these are color coded like this. Just maybe to differentiate each one. I'm not sure. I don't know what they're doing here. Oh, okay. So this is the Hubble with pick 2. So yeah, that's probably Saturn. Extremely overexposed. 40-second exposure, and I guess maybe one of these is Titan. It's probably the bright one. That's kind of cool. So yeah, that's all the HST images there. What do we got here? It's kind of weird looking. Oh, come on. Okay, so this is the NICMOS camera. I'm not quite sure what's going on there. That, yeah, it's really hard to tell. I'm not sure what's going on there. It looks like 3 different exposures. With Saturn being overexposed, it looks like in all of them. So yeah, it's really hard to tell what's going on there. We could probably look this up over on the HST site and see if there's any more info. But yeah, let's just keep going here. It looks like a lot of them are like that. So yeah, I really don't know what's going on there. Any ideas why that's like that? It's supposed to be looking at Titan, but that's kind of hard to tell what that even is. It's a little weird looking. So yeah, I don't know. This live stream is not about answers, it's about questions. Absolutely. So I'm not quite sure what these are. This looks, it's really hard to tell if this is Titan itself or if this is just overexposed Saturn and Titan is out here somewhere. Yeah, I'm not gonna even try to guess. It's sort of looking though like, oh, that's a little tiny thumbnail. Maybe Titan. It looks like Titan. HST again. Whoop, did I just get rid of that? Yeah, I did. Hey, let me get it back here. I've got to save this as a link at some point. Woo! Wow, we really. Here we go. Search again. Well, since we're no longer there, I'm kind of curious about this other. What is this other here? Okay, so it's just, it looks like it's a bunch of asteroids. The ring of Chiriclo. Have you heard about this one? This is one of the asteroids that has a ring around it. I talked about this in one of my podcasts, the Apogee podcast, over on 365 Days of Astronomy back in like 2014, 2015. Really, really cool. There's an actual ring. There's a ring around this asteroid. Browse results. Oh, okay. Well, we're not going to see much. Nope. Just some streaks here. Here looks like maybe the asteroid right there. Chiriclo, I believe is how you pronounce that. Yeah, there it is again. All right, well, let's keep moving here. Should be going back. There we go. So, okay. Well, let's take a look at Jupiter. We can look at all of Jupiter. There's 183,932 entries there. We can knock that down to just Jupiter. I don't know what a double Jupiter means here, but that's a little weird. But let's see what this shows. Okay, yeah, just lots of images of Jupiter from Voyager. That's pretty cool. Probably looking a lot in the ultraviolet. It doesn't say here. I don't remember what the ISS is. You can probably find out. Voyager ISS. Imaging Science Subsystem. Eight filters, 2 television type cameras, they call it. Okay. Interesting. Anyway, so yeah, I don't see anything about wavelength or anything like that, so I'm not sure. We'd have to get into this a little bit, I guess, to really Oh, here's the whole optical calibration target. Planetary radar, plasma science. Huh, where's our, I guess, okay, I guess this is just the imaging science subsystem, but yeah, they don't say anything about wavelength or anything like that. Oh, yeah. Okay, well, I'm not going to sweat it too much. Let's continue to look at Voyager images of Jupiter. Wow, that's pretty nice. Oh, there's a shadow. Yeah, there's a shadow on the planet there. Don't know what moon that is, but you know what? We can find out. We have the technology. Let's go back to this. We've got a date and a time. We can actually go over to that site, type in a date and a time. I'll have to format this a little bit, but that's no big deal. It'll probably accept that format, but just to make sure, I'm going to put it into that format. 1500 seconds. Now, of course, it's not going to look like this. This is the view from Voyager, not from Earth. So things are going to be a little weird, but yeah, I'm thinking that if it's casting a shadow, then it's going to be, we're going to know which one that is just by looking at this, I think. Place your bets. You ready? Lay down your bets. I think we should be able to figure out which one it is. Whoop. And that's my bad. I was talking instead of thinking. 1779. Yep. Okay, here we go. Place your bets. Well, let's zoom in a little bit because that is inconclusive. It's going to be a little stubborn. Let's zoom in 5 times here. That'll make Jupiter look really big. And we'll see what the situation is here. All right, well, it's either Ganymede or Io. Either one of those. The only way that we can really know is to look an hour beforehand and see which way these guys have moved. If they're moving west to east, if they're going this way, then they're actually behind Jupiter. They're on the other side of Jupiter right now. If they're moving east to west, this way, to the right, then they're on our side of Jupiter. And the one that we want is on our side of Jupiter because it's casting a shadow. So let's go back an hour and see. You can sort of, well, you know, what I should do, I really want to do this right, is let's save this image. Let's see, we'll put it here. 180726. We'll call this Jupiter 1. Actually, we'll call this, well, yeah, Jupiter 1, and then we'll go ahead an hour. Let's go ahead like 3 hours. Okay, so let's go like 8, 19. Then we'll really know. Oh yeah, I think we already know. I think I already know. So Eo's moved way over here. Ganymede has moved this away. So that is Eo, and that's Eo's shadow. Can't really see any details or anything. Plus, you know, this is a JPEG, so all bets are off when it comes to that. But beautiful Jupiter, nice shadow, very cool. That's Eo. Eo. Let's see what else we got here. Lots and lots of Jupiters, of course. If you're flying by, you take as many pictures as you can possibly take, as fast as you can. Yeah, there it is right there. Maybe this is a different date, but there is definitely a moon there. What is that? Yeah, that was taken the next day. Wow. Maybe there's a moon down here. Kind of hard to tell. Looks like a moon, maybe. Yeah, here's something way up here too. So yeah, lots of action up there. Pretty crazy place. Wouldn't want to get stuck there too much. Lots of pictures, lots of different colors. That's pretty much what they're doing here, is just snapping pictures as fast as they can with as many filters as they can. Wow, there's a lot of them. I had no idea that there were this many. They were really snapping those things fast. Wow. Yeah, that's pretty amazing. Let's really go forward here. Oh, look at that. It's bigger. Wow, look at that. Ooh. Wow, that's big. That's really big. I don't know what these little things are. Do you see those? These little things here? Don't know if that's part of the JPEG is just having some problems with those little areas, or what exactly those are. That's a little weird. Don't I don't really see any kind of regular pattern. Those are the only two I see on this whole thing. So yeah, I don't know what that is. Amazing shot though. All right, let's go forward a little bit. Was that still Voyager? Did we ever figure that out? Let's find out if that's still Voyager. That's Voyager, yeah. Come on. There you go. I'm just going to add a little bit of brightness and contrast with GIMP. I take a gulp of this nice HOH here while this is loading. I think it's loading. Yep. GIMP is really amazing for those of you who don't who don't know about it, it's basically Photoshop, but it's free and it's open source. And I've used it for years. Now it's running really slow because my poor computer is just having a rough time. But let's see what we can do here. Go into RGB mode and then maybe just try this first. Kind of cool. Let's see what else we can get out of this thing. Just auto stuff. That's kind of neat. Yeah, pretty nice. Oh. Levels. Color enhance, normalize. Nah, that's not going to do anything. Okay, so let's just play with the brightness and contrast here a little bit. Let's see what we can see what I can do to play with things a little bit. Yeah, well, pretty nice. I'm thinking that if we were so inclined, we could probably get this same image with at least 3 different filters. Might have to do some realignment and stuff, but yeah, let's just keep going here. Ooh, that's a pretty good shot of the. Wow, I guess that's the red spot, huh? That's pretty intense. Yeah, pretty amazing. Let's look at that one. Here we go. This one. I'll just do exactly the same thing. I'll go right to brightness and contrast and see if we can mess around with that at all. I really like all the Ripley stuff. I think everybody does. That's a really cool aspect of Jupiter. Yeah, quite a place. Quite a place. You can fit at least a few Earths in there. So yeah, it's a pretty intense place. Nobody really knows what it is. It seems to be spinning, rotating. But yeah, why? Nobody knows. Nobody knows. We probably never will. I don't know. It's there's an indication that it wasn't always, or at least not in recorded history, the red spot always being there. So yeah, hard to know for sure. I'm sure there are lots of theories. Okay, well here's some famous shots. Got to get the EO with Jupiter in the background shot. Yeah, that's pretty awesome. Let's see if I can play with the brightness and contrast again there really quick. Yeah, this is a pretty amazing sight. And again, this is only one of the links. So, wow. There's a lot here for sure. Yeah, it's really an amazing shot, an amazing place. For sure. Let's get a big one of the EO here. There we go. JPEG'd up, so it's all wrinkly. But you see a lot of detail on the surface there. It's absolutely fabulous. A lot of changes in albedo, um, reflection. You see how dark it is here and how bright it is here. So yeah, kind of interesting. That's kind of an interesting shot, showing half of the moon, right? The half that faces us. Cool. Well, let's what is all this? That can stay. Let's zoom way forward here because I'm looking at the time and I'm noticing things. Oh wow, okay, this looks like artwork. It looks like my kind of artwork. Yeah. So that's from Cassini, and well, dang it, I'm not seeing a lot of detail there. Almost make out Saturn's rings, I guess. Huh. This must be calibration data. That's all I can really think. There's a lot of it, and it repeats. So that's my guess. You know, they're doing exactly the right thing. If this is calibration data, then yes, you take as much calibration data as you can possibly stand. Yeah, so this is the Cassini mission when it passed by Jupiter. So this isn't the Cassini mission at Saturn. This is how it got it out there. Was a nearby pass of Jupiter to sort of fling it around. So there you go. You good? I'm gonna get rid of that. A little overexposed here, it looks like in the center. What was the 3.2 second exposure? Yeah, pretty interesting. Okay, more calibration data. More Jupiter data. Okay, why don't I skip forward a little bit? Skip forward a little bit more. Oh, more calibration. Don't quite know what that is. That might be Jupiter still from Cassini. Let's see. Yeah, okay, so it's still got a lot of Cassini data in here. Oh, cool. Is this with HST? Yeah, okay, so this is HST looking at the aurora on Jupiter. So if you didn't know that there was electrical activity on Jupiter, there you go. There you go. And actually, they're talking about these points somehow being connected electrically to the moons. So yeah, kind of interesting. But that is definitely an aurora. Don't know if it's the North Pole or the South Pole, but kind of cool. Taken with HST. These look like spectra almost. Yeah, I think this is a ultraviolet spectrometer of some sort. So yeah, this is just this is the data as it comes in. So not quite sure what they'd be looking at here, but this is now frequency space. We're looking at spectral data, not image data. So yeah, it's hard to tell, but up and down might be wavelength. Yeah, it's hard to tell. Oh yeah, here's a nice one. Look at that. Isn't that fabulous? Beautiful. Aurora on Jupiter, taken by Hubble. Probably in the ultraviolet. That's where this stuff likes to glow. I don't think that they get a lot of visible light events like this. I don't think they do. Maybe they do, but I'm not sure. I don't think so. So I don't know if these are Jupiter's rings. That doesn't. Yeah, no, this is more spectral data again. Yeah. This is the ultraviolet spectrometer again. So yeah, it sort of looked like spread out rings, but no, this is a spectrum of some sort. Yeah. Yeah. More calibration data. It's good to see all of that. It's um, if I were a scientist wanting to use this data, um, one of the first things I ask is, how do you calibrate it? How much calibration data do you have? And well, the answer here is, wow, they've got a lot. So this looks all like HST data. Go all the way to the end here. All right, so what have we got? Hubble, Wide Field Camera 3. Is that the red spot? Wow, that's weird looking. Isn't that weird looking? 6-second exposure back in 2017. Yeah, I don't know. The red spot looks a little weird and dark there, but maybe that's just me. But yeah, there's HST. Pretty good resolution for a, what is that? A 6-second exposure. And things up there are constantly changing. So you'll look at this patterning now, and next time you look, it'll have changed a little bit. It's a very, very dynamic place. Cool. So more HST, and it looks like different wavelengths. See, here's one. It doesn't say what wavelength. We'd have to look it up somehow, but I don't know if that could, if that would be in the infrared or in the ultraviolet. Yeah, it's really hard to tell. I'm trying to go by the name here, and I don't think there's any spectral information in the name. Oh well. Add to cart. Huh. Oh, show detail. Ooh, let's see what that does. Let's see if it gives any spectral information. Image constraints, wavelength constraints. Aha, there we go. So yeah, that's very much in the infrared. 0.8843 microns is 8,843 angstroms. So yeah, that's pretty much into the red part of the spectrum. Well, this is really nice. Wow, look at all this metadata here. That's great. And look, you can grab the full size. Yeah. So cool. I don't know what to make of this this weird patterning. I don't know what's going on there. That looks a little strange. Well, that's pretty cool. All right, you can let's go back here. Oh. Uh-oh, it's not wanting to go. Not wanting to go back. Or maybe it's trying to, and I'm not letting it. I don't know. Well, I can go this way. Come back to here. All right, well, since we've come back to the beginning of this, probably a good place to stop for today. But yeah, there's, and sorry, I still have to come at it this way because I don't have a bookmark. I should bookmark it right now, huh? Done. So yeah, there's a bunch of other things here too. Maybe, you know, let's spend one more day on this. I'll try not to get so caught up in you know, the details. We can take a look at this a little more thoroughly. And yeah, you know, tomorrow, let's definitely make that the last day here. There's always so much to talk about in terms of astronomical stuff. So, all right, definitely want to take a look at the chat. Andy, hey, nice to see you. All right, well, cool. I think it is about time to get out of here. For some reason, throat's all scratchy, and this is not helping. Who knows? Anyway, so I'm going to get out of here before this is completely gone. All right, everybody. Take care. Peace, cheers, and all that. Have a great evening, a great day. I will see you in a little less than 23 hours. I will be here tomorrow, 2 hours UTC. We'll take a look at that site just one more time, and then we will move on. We will move on. So, okay, everybody, take care. I will see you on the spin. See ya. Bye.